sorry for being gone for so long. I'm finally back. I'm going to be making like a video every weekend. Yeah, this university has been draining the life out of me. But let's just get started. So this is multiple calculus, just one of the tutorials that we are asked to do. I'm just gonna complete that and we'll go to something else. First question. Alright, so first question. The first question is a particle moves in the x-y plane in such a why is this so okay in x-y plane such that its position at time t is t minus sine of ti plus 1 minus t cosine of cool. So you wanna first of all graph this thing. The resulting curve is a cycloid. Yes, it is a cycloid. Find the maximum and minimum values of v and a. So just try to graph this thing. Cool. So this is our t-axis. Actually, no, t is a parameter, right? So just got the x and y. So at equal to 0, it will be like what? It's just 0 minus 0 is 0, and then that's also just 0. So it's at the origin. Then initially, this guy's velocity is like so just v is equal to 1 minus cosine I plus what? It's just that. Yes, that just cancels. So just sine of j. Cool. So at 0, it's just going to be like what? It's just 0. Sure, that doesn't really help. But yeah, it's more in the j direction because of the Taylor series expansion. So what's gonna happen is it's gonna move like this, and yeah, so it yeah, the y coordinate is like 1 minus cosine of t. Sure. So its maximum value would be something like, so this is 1 at most, so it's 0, and otherwise and initially it's at 0, right? Okay, but so its velocity is 0 here, both in both directions, isn't it? Did I do something weird about? Nope, it's all correct. I think it is 0. Cool. So okay, what about the acceleration? Where is the acceleration? The acceleration is just sine I plus cosine of j. So how am I gonna tell? Okay, so at 0 this is like 0 plus so cosine j. Yeah, sure. So it's above. What does that mean? It's a cycloid, right? So the acceleration being above, what that kind of means is this, but it is supposed to be in j direction. Yeah, that doesn't quite make sense. It has no velocity initially. Sure, so it's actually gonna go like that. Cool. Fine. So 1 minus cosine of t, huh? So it's t comma 1 and it's revolving around that. So that's this line, and it is revolving around that. Well, initially it's just vertical, isn't it? More vertical than horizontal, suppose. It's kind of hard to explain what's going on, isn't it? I know it's gonna be circular and all, but still. Do I really have to graph it like, just pointwise? I guess I do. So I'm just gonna go with it like that. So at t equal to 0, it's here. At t equal to, I don't know, let's say, sure, so at very small values of t, this would be something like, so t minus sine t, so sine t is like something like t minus t cubed by 3, right? 1, 3 factorial, I think, so it's just 6, sure, so just t cubed by 6 I, and then 1 minus, so it's t square by 2, cool, so just plus t square by 2 j. So this is the more prominent term, so it's going to be something like, it's going in this direction. Well, okay, we want the ratio of these, don't we? So it will be something like y equal to x to the power of 2 by 3, some constants, times some constant. Cool. So okay, that's not like, so it's not like this, it's something like this. Cool. That's the only thing that we have right now. Cool. And then wait, so what's the minimum y coordinate this is gonna reach? It's 0, right? Sure. The maximum would be 1, minimum is 0, so it's something like this. Yep, that's just how a cycloid is. So this thing is 2, it's going around 1, and yeah, I guess that's the graph. What's it's so yeah, when this thing happens is at t equal to 2 pi, I guess. Sure, so at t equal to 2 pi, what is this gonna be? Just 2 pi minus of, well, that's 0, so it's just 2 pi. So this thing is 0, 2 pi, 4 pi, etc, etc. I know I'm really slow right now because I really just haven't had practice in who knows how many years at this point. But yeah, let's just keep going. So B is find the maximum and minimum values of V and A. We've already found V and A. So V was just 1 plus 1 minus the cosine, and then comma sine, and then the acceleration was just what, sine comma cosine. So you want the maximum value of the magnitude. This is just the square root of that. The square root of just what, which is like 2 times of 1 minus c. So 1 minus c is just 2 times of sine squared by 2, theta by 2, right? I mean t by 2, whatever. So that is going to be like what, 2 uh, 2 magnitude of sine of theta by 2. Sure. So this thing is 1 at max, and this is 2, so it's going to be 2. So it's 2, and for acceleration it's just 1 because it's unit in any case. Cool. What about c? C is, so there's no c. Okay. Second question. The second question is evaluate this integral. So it's just what, 1 upon t. Oh, I mean, come on. So just natural log of t from 1 to 4. So it's natural log of 4. Are you serious? So natural log of 4 comma, yep. So it's just like split it into I, j, k coordinates. This is just a scalar, so it doesn't really matter. And then you got dt over there, so just natural log. So negative natural log of 5 minus t. Cool. So it's like natural log of 5 minus t from 4 to 1. So that also just happens to be natural log of 4 comma, so once again just 1 upon 2 natural log of t. So oh yeah, it's just 2 times it, so sure, it's a natural log of 2. Cool. Third question. Third is, oh, it's actually 2, so it's a and b over there. This thing is a, this thing is b. B is this integral, I mean, okay, just 3 integrals essentially. Just cosine of t dt. This is the usual thing, so just like sine, just sine of 0. Sure, so 0 to pi by 2, pi by 2 it's 1, it's just 1 comma, minus sine of 2t is just half, just negative 1 by 2 cosine of, oh wait, negative cancels up, so just 1 by 2 cosine of 2t from 0 to pi by 2, and that just happens to be like, this is 1 over there, this is minus 1, so minus 1 minus 1 is minus 2, so it's minus 1. Cool. The sine square of t from 0 to, oh, this is a well-known fact, it's just 1 because obviously it is 1. Like, I mean, come on, you don't believe me, just 1 by 2 times of 1 minus cosine of 2x, integration of that dx from 0 to what, pi by 2. So just like 1 by 4 d2x, or you can just take that 1 by 2 off, so it's just 1 by 2 times of pi by 2. It's kind of weird, isn't it? So this thing is like going from 0 to, something is really messed up about this. Sine square of t dt, isn't it? Yeah, so there should be 1, right? And why is it not 1? I messed up somewhere. So it's just like what? Yeah, I messed up. So it was something like that. This. So it's 0 to pi by 2 sine square. Oh, it's sine of t dt, which is, that's 1. This is not, right? And then the same thing can be written as 0 to pi by 2, so just by symmetry cosine square, because pi by 2 minus t, what is it called, the queen property or something. So they just got 2 i's just equal to, yeah, that's how it is. So just I equal to pi by 4, that is how it's supposed to be. I messed up somewhere, sorry for that. So just pi by 4, not 1. Sorry for that. I'm sure it's pi by 4, right? I mean, it has to be pi by 4. Why is this so weird? It's okay. Let's move on. Question number 3. Question 3 is solve this differential equation dr by dt something. Initial conditions is r of 0 equal to whatever. So just r is, I suppose, it's a vector rule. So just we can just break this into 2 differential equations. So dx by dt equal to 180 times t. and then dy by dt is equal to 80t minus 16t square, something like that. Solve this thing. What you get, you just get x is equal to 90, I mean, yeah, integrate plus t square, 90t square plus some kind of constant, and then y is just what, the same stuff, 90t square plus some constant, okay, minus of this stuff, so just t cube by 3, so just minus 16 by 3 t cube plus some constant. Okay, and given like r of 0 equal to 100j, so that means this constant is not there, and this is supposed to be that all of that is cancelling out, so just that c thing is 100, so it's 90 t square comma 90 t square minus 16 by 3 t cube plus 100. This is just really really bad. I mean, like, why am I even doing this stuff? Just move on, just move on, keep doing it, just get it done. A volleyball is hit when volleyball is hit when it is 4 feet above the ground. 4 feet, whatever, 4 above the ground, sure, and 12 feet from a 6 feet high net. So this is a 6 feet high net, then it's 12 feet away from that. Okay, you mean the horizontal distance, right? It leaves the point. I'm not sure it's the horizontal distance, or do you mean something like this? This is supposed to be 12. Yes, and this would be 2. It probably doesn't give us 9 numbers. I mean, it doesn't give us nice numbers. I think this thing is 12. Anyway, it leaves the point of, yeah, I guess 12 feet from a 6 feet high net. I don't know. Oh, so when you say net, this whole thing is like, oh wait, no, volleyball net isn't like a football net, sorry, so it's something like this, fine, and it's over here, so it's kicked like that, I guess, whatever, so it's hit. I really don't know if this is the horizontal distance or the vertical distance, so I'm gonna assume it's the horizontal distance. Okay, it leaves the point of impact with an initial velocity of 35 feet per second at an angle 27 degree. It's listed by the opposing team untouched. 27 degree, why that? 27 wasn't really, this was like 53 and 37, those were the numbers for 3 by 5 or something. 27 isn't something I've encountered. Okay, at an angle of 27 and slips by the opposing team untouched. Fine, find the vector equation for the path of the volleyball. Really? How high does the volleyball go, and when does it reach the maximum height? Find the range and flight time. And so okay, how far ground distance is the volleyball from where it will land? Supposing that is raised to 8 feet. Does this change things? Okay, cool. So you just need to find this stuff. I mean, if it's gonna hit that, so sure. Okay, so yeah, so I'm just gonna reduce everything by 4, so this thing will be like 2 essentially. So it's 27 degree up, right? So cool. It leaves the point of 35 per second and 27 degree. So our theta is 27 degrees. Bad, but whatever. The velocity is something like 35 feet per second. What is that in meters? We will have to convert off. What's 1 feet in 1 meter? Well, 1 feet is like 30 centimeters. This would be something like 35 times 0.3, I suppose. It's 30 centimeters, right? I don't remember. Was it 30 centimeters? I think it was 30 centimeters. But yeah, it's just this many meters per second. So it just has 9 and 15 square 105. Sure, it's just 10.5 meters per second. That thing is our velocity. Okay, just by the opposing team untouched. Find the vector equation for the path of the, the parameterized equation, I suppose. So let's just find the x coordinate. Vx is just this thing, cosine theta. Cosine. How do I know the cosine of 27 degree? I don't. What do I know? Oh, I know the cosine of 57 degree. So it's just cosine of 57 degree minus 37 degree. Then. Is it 30? No, that was 53. Oh, but I know the cosine of 37 degree, I think. Yeah, I do. how do you find 27 degrees then? That isn't doing helpful. 27 degrees like 30 degree minus 3, not helpful. It's like 60 degree minus, no, gonna work. 33 isn't a number that I can use. I think that's 7 somehow. That would cosine of 7 degree. Sure. I don't know about 20 degree. Nope, that's not gonna work out. For 20 degree I'll have to do some really bad algebra. I'm just gonna approximate this as 30 degree. I know, not a very nice thing to do, but I'm just gonna say that's approximately 30 degree. So it's just half over there. So then it's just like what, 5.25 meters per second, and then y, that's just gonna be like square root 3 2 by 2 of this stuff. So just 5.25 square root 3 meter per second. Cool. 41. Find the vector equation. So sure, it's just you know what, like I'm gonna give them the real vector equation. So yeah, sure. So you already have the 4 thing, doesn't matter. So it's just not this thing, it's supposed to be 10.5, then cosine 27 degree, that terms of t, that's the velocity, that's meter per second, this will be in meters, and this thing, the coordinates. So just what, so ut minus half at square. So what is this? I already have the 4, so plus what is this thing? It's just 10.5 sine 27. What am I even writing? Degree t minus half t. So just 5 basically, approximately g equal to 10. So just t square. That's your r vector. Okay, we want to know if this will actually hit this net. So the net has coordinates what? It has coordinates 12, 6. Sure. Oh, that's in feet actually. Oof. It's in feet. I would just put feet over here as well, right? But then what's g in feet per second? I don't know. It's a problem. But anyway, so just 12 feet, which is like 12 times of 0.3, I suppose. So it's 36 and point is 3.6. So it's 3.6 meters away, and then just like, oh, that is 4 feet. I can't be doing that. So it's 4 times 0.3, which is like 1.2. So it's 1.2 meters. So this will also be like 1.2 meters plus the other stuff, which is 2. So 2 times of 0.6 is like 0.6 meters. 0.6 meters. So it's basically this thing that we care about. So just 3.6 is equal to 10.5 cosine of 37 degrees times t, and over here what you have is this stuff, which is 10.5 sine 27 degree t minus 5t square. That has to be equal to 0.6. Now what do we do with it? Well, we want to find the t value, so just divide by sine, this by cosine, and subtract, and you get t square, and that's it. Do I really want to do all that calculation? I mean, I'll have to. This is really not good, but sure. So what you get is get 5t square, so when you subtract and all, is equal to, so 3.6 upon cosine of 27 degree minus 0.6 upon sine of 27 degree. Sure. Yeah, I guess this looks okay. So just t square would be this thing upon 5, or that's like 0.10 times 2 is just 7.22, this is 0.72. 0.72 upon cosine 27 degree. I don't need more space to write this. Yes, as you can see, I'm really rusty with everything, even this. This and all. So t square is like what is just is upon 5, which is something like 0.7, and then it's 2 cosine 27 degrees minus the stuff upon 5, which is like 0.12 upon sine of 27 degrees. So t is just the square root of that. Sure. So that's, you found your time coordinate. Okay. So yeah, if they do meet, something like this will happen. Oh, at the same time, what has to happen is, oh, so that's just solving. So both of those must also be satisfied, right? Yeah. So plug in the value of t and this should actually work out. So the difference will actually work out. What about the sum or something? Are these two consistent? It's a good question. You can also try to eliminate t square, huh? To get the value of t. Now, oh, that's actually pretty easy. I mean, t would just be equal to 3.6 upon 10.5 cosine of 47 degree. Right. So I could have just used that directly. So that has to be equal to this number. If they are the same number, we are done. But are they the same number? How will I know? I don't know what cosine 27 degree is. Nope, they won't ever be the same, because the thing is like, so square of this, and then cosine 27 degree is approximately like cosine of 30 degree will have some sort of 3 by 2 stuff going on. I don't know, they'll match if this happens. Okay, anyway, the point was, find how high does the volleyball go. So if these are to be consistent, then this should happen. Okay, on okay, how high does the volleyball go? Well, just put, I'm just gonna maximize this stuff. So what, just minus b upon 2a and all that. So it's just yeah, I hate this. I don't remember the formula exactly. So this is like what, minus 10.5, this inverse b 10.5 sine 27 degree upon 2a, which is minus 10, I guess. So it's just this, that's the t value, and it reaches the peak. Just put that over there and see what happens. Just 1.2 plus 10.5 times t is this stuff, 2.5 sine 27 degree squared upon 10 minus 5t squared. So once again the same stuff, squared upon 100. So now it's going to be the 10.5. So it's minus 20 essentially. Just got that. Just 20. Yeah. So that's this is in meters. And that looks okay. Meters. That's fine. Alright, cool. Did I have to find anything else? Yeah, the range. I don't know what the range will be. It's either this 12 feet or it's the full range, right? What about the pole that this is a weird question. Okay, I guess I'm gonna be, I don't know. Okay, just find the full range if possible. So it's gonna be 0 at what location? Hey, so you don't really need that, do you? No, you have the formula. So it's just gonna be like what, u square sine of 2 theta upon g, if I remember correctly. Yeah, it's probably that. Cool. Which is what, so just initially it's like 35 feet per second, which happens to be 10.5, so just 10.5 squared sine of 2 theta. I don't know what sine of 54 degree is. Oh, sine of 54 degree would be approximately like sine of 53 degree, which happens to be 4 by 5, I guess. So around 4 by 5. Cool. Upon the g thing, just 10. That would be our range. Yeah, so this will be our range. It's in meters. What's that? It's approximately something like so just just got 100 plus 2 times of this times 0.5 is like 5 times of shots is 10 plus 0.5 is like 0.25. Okay, 5 times of this stuff, which is just 4 by 5, and upon 10, that's just like 10 plus 1 plus you gotta do 4 by 5 as well, so 4 by 5 would simply like 0.8, so 0.8 over there. So this thing 5 times of 0.025 times 0.8, which is like 8 plus 0.8 plus so this times of 8 would just be like what's times of 4 is like 0.1, that is equal to 0.2, that is just 0.02, which would be something like 8.82. So this is approximately 8.82. I don't know if what I'm doing is actually correct or not, but like, who cares? Okay. So wait, 8.82. Oh, the range is much less than. What was the full thing? Yeah, that was 12 feet times 0.3, right? That was like 3.6. Oh, it is actually more, much more, in fact. Yeah, I don't know if it's gonna work out. Right. Never mind, just move on. Okay, there was a D as well. Where is the volleyball? 7 feet above the ground. How far ground distance is the volleyball from where it is land? I really don't want to use the G thing and all that. Velocity of, so it's gonna reach 8.82 meters. This is like 3.6 meters, so I would say it's okay. Okay, cool. So when is this 7 feet above the ground? How far is the volleyball? Sure. Just gonna use these equations and be done with it. I actually don't know if this is a consistent thing, but well, whatever. So D sin theta. So 7 feet is like 2.1. So 2.1 equal to this stuff, which is 9. 0.9 equal to 10.5 sine 27 degree T minus 5t. No, I don't want to be solving this quadratic. So whenever that happens, and at that point we want to figure out the value of 0.5 cosine 27 degree. So 10.5 cosine 27 degree T. Yeah, you will have to solve this, won't you? Well, you can certainly figure out when will this happen. So just 5t square minus 10.5 sine 27 degree T plus 0.9 equal to 0. So something like t square minus 2.1 sine 27 degree plus, okay, 0.5 sine 2.10, and then it's equal to 1.8, so 0.1 equal to 0. Otherwise minus b is just 2.1. So it's just horrible. So 27 degree, this is called as S for now. So it's just 2.1 S plus minus, so it's gonna be, the minus thing probably doesn't make sense, right? It's just plus instead of b square. So just, yeah, I don't think the sin feet will make sense that way. Minus 1 would be like b square is 4. So this is the positive, it's gonna be negative. Oh, I see. So it's probably the minus 1 which I should be using, because that's the first time it actually happens. So minus square of this thing squared, so it's just sure, what's the 1 square is like what, 4 and 4 and 1, so it's just 4.41 s squared minus 4ac, so just 4 times of this stuff, so it's like 4 and then 32, which is 0.72 upon 2a, so it's 2 essentially. Yep, that's when this happens. So yeah, just gonna delete all of this. So this will happen at t equal to this quantity. I don't know what this quantity is actually. It's like 1.05 sine 27 degree and minus the square root of, so that goes inside, it's 4 over there, so just 1.025 s squared, so sine 27 degree squared, minus this upon 4, so it's just like 0 point, and then got 132 into 8, so it's about 1.8. Oh, we already did that already. 1.8. This is, well, I can just write as s27. Yeah, probably typing it is easier for me at this point, because oof, I haven't done it for ages. Like, I'm really slow. But anyway, let's move on. So this is like some, oh shit, I deleted a lot. This is like some basic kinematics question, isn't it? Okay. D is done. Suppose that the net is raised to 8 feet. Does this change things? Explain. I don't know. I honestly need the values to be able to figure out anything. Well, if it's 8 feet, then this value will actually change, right? Yeah. Point is, like, at this time, what will the y coordinate be? Right. Whatever is the y, just really need to know what sine 27 degree is, don't we? I think I can just use a calculator. Like in the exam, I won't be needing that, but sure, I'm just gonna keep it like this for now. So I won't answer this question yet. I wanna do it like the authentic way, the original way that we have been doing this. So the net, whenever it reaches net, in 2 different ways. So this one is using x coordinate, this is using y coordinate. Next, okay, this was about question 4. Let's go to question 5. Question 5 is this is question 6, I think. Okay, in something something something, set a woman's world record something something short 73. What does this even mean? 8 lb, that's a weight or a force. 13 was shot. OZ, what is this? Assuming that she launched the shot at 40-degree angle to the horizontal from 6.5 feet from the ground, what was the shot's initial speed? Oh, so the range is, I think the range is given as 73 feet and what, 10 inches, I suppose. So I think 1 feet is like 12 inches. I don't remember. It is certainly 30 centimeter, right? Okay, so 30 inches is 1 meter. So 1 inch is just 1 meter upon 30. Oof. Anyway. So okay, short. Oh, so this is just the weight, in fact. Like, it's not, it's gonna matter because we just talking about speed. So she shot it like at this, fine. Okay, assuming that she launched a shot at 40-degree angle to the horizontal from something feet above the ground. Oh, it's all in feet. So I'm just gonna divide it by 12. I think an inch is just shit. We need the value of g, don't we? What was the slope's initial speed? Sure, just want u. So the thing is like r equal to u square sine of 2 theta. We are given what theta is. So it's 30 degrees, so just 80 degree over there. Upon g, shot to the horizontal line. Oh, so she shot it from 6.5 feet above the ground. Okay, something like this. This thing is 6.5 feet. She shot it like this at 40 degree, and then it went over here, ground, I suppose. I think. Okay, cool. Slightly different than what I was expecting. So this whole range is what we're calling R. Fine, makes sense. So yeah, so it will just be like negative 6.5 feet. That's equal to your so just like the bigger one. Sure. Okay, so it will be something like 2u uy something 2u sine theta upon g. That's the time required to reach this point. Okay, After that you need this thing, so it's like half t square, so it's just, so 6.5, that will be like g by 2t square. Sure, so it's just something like 13 feet by g, the square root of that, that's a time for this thing. Okay, and that plus this time, so just 2u sine theta upon g. Sure, that is probably the time required, and this times of the x velocity, which is just u cosine theta. Right, that's the range, so that's what r is, which just happens to be, oof, it's gonna be some calculation. So 13 feet upon g plus, sure, so this thing is, oh, not that, but times of u cosine theta. We want u in the end, don't we? Yeah, whatever, and they just got plus u square sine of 2 theta upon g. Cool. And this thing is going to be equal to r, so you got something like sine 2 theta upon g u square plus this stuff, is just cosine theta square root of 13 feet by g u and minus r, so is equal to 0. Sure, that's the thing. Okay, just plug in some numbers. Actually, don't plug in some numbers, just so equal to minus b. So what we want is just the u thing, right? Sure. So let's not even call it 13 feet, let's just call this thing as h, small h. Sure. So h is 13 feet. The r thing is our range, which is 7 feet and 73 feet and 10 inches. And the time we don't really care. Theta is just 40 degrees. Okay, so just find the u value, so just minus b is, can I simplify this further? I don't need to, that's the point. Minus b, I should probably simplify this further. This thing is g over there, that is over. Yeah, let's simplify this. So that's something like u square plus, so that g is square root of hg, sure, cosine theta upon sine of 2 theta, that's going to be something like upon 2 sine theta, u minus this stuff, so just rg upon sine 2 theta, this minus b is this stuff minus, it's going to take some time, square root of hg upon 2 minus b plus square root of b squared, this stuff squared, which is just hg upon 4 sine squared, times 4 ac, so just plus, so plus 4 times of this, 4 rg upon sine 2 theta on 2a, so just 2 at this point, so that will be our u value. Cool. What's that gonna be? Can I simplify that further? Just minus, that goes over, sure, it's just minus square root of hg upon, yeah, right, so this same thing could have also been reached with either a higher or a bigger velocity or smaller velocity, right? Or sorry, a smaller angle, something like that. One of them is going to be positive or negative, right? This can't be negative, this has to be positive, because if it were negative, something really bad would happen. So this is square root of hg upon 4s plus, this goes inside, so it's just hg upon 16s squared, oof, really bad, plus rg upon sine of 2 theta, whatever this quantity turns out to be. Did I do everything correctly or not? So just do square sine 2 theta upon g, that is the normal range, and then plus you would also require a time to fall down, that's going to be, so u cosine theta times the time to fall down, which is the square root of h upon g, right? Oh no, it's actually 2h upon g, so sure, right, so everywhere you just want to put 2. 2h, square root of 2h. This would also be 2, so it's going to be upon 2 over here. This as well, so you just have square root of 2, so it's going to be, actually you know what, just put the square root of 2 over there. Right, and over here it's going to be that 2, it just makes this 8. Right, yeah, that's better. Okay, this is the time required, and that times of set it down. Cool, I think it's okay. Just minus b is just minus cosine. And then I divide it by the whole thing. Yeah. It's 1 4 centimeters. Sure, it's okay. So this is our value. So yeah, just remove all of that. This thing is our value. Okay, let's start calculating what this thing really is. It's just minus square root of 2h. So h is this. What is g going to be? That's the problem. What is g going to be? How would I know what's g going to be? I don't know what g is in feet per second to 1. So what do you want? What was short's initial speed? I guess the best way is just to convert everything to meters. So h would be something like 13 times 0.3, which is like 3.9 meters. R would just be 73 feet and 10 inches. So that comes something like 21 and 9, so just 21.9 meters plus this 10 in meters, right? So I think 30 inches is 1 meter, so it's like this upon 30. So 1 by 3, so it's like 0.3 approximately. So this will 0.33 is better. So just like what? So something like 22.23, right? 22.23. And then just put g equal to 10, I guess. Or should I go the more masochistic way and just say that g is equal to, you know, I guess, yeah, so it's g equal to 9.8 and theta equal to, you know what, I'm not gonna do this because theta equal to 40 degree, I don't know what sine of that is, so let it be. Just have this formula, give them this thing and tell them that, oh, just put this in a computer. I'm not like going to calculate all of this. Sure, oops. Yeah, that's it. That's question number 5. That's what question. So that's actually the better way to be doing these problems, because in the end I'll be using computers in any case. So I'm just gonna write down the values and then give them the formula. That's it. Projectile motion with linear drag. The main force affecting the motion of projectile other than gravity is its air resistance. This slowing down force is the drag force. It acts in a direction opposite to the velocity of the projectile, whatever. For projectile, however, the force is varying in proportion to the speed of the first power, and it's linear. Okay, so derive these equations, x is whatever differential equation. So basically you just want these things. This differential equation is given, d square, so that's our acceleration, that's equal to negative g and all that. So g is just like the gravitation, okay, cool, minus k times of v is just the velocity. Sure. Initial conditions is given, shouldn't be too hard. So okay, so what is this? It's in 2D, isn't it? Yeah, let's not do that. Let's not try to use the r sign, the re bar I theta stuff. That's probably not a good idea, right? Or is it? Or is it not a good idea? Okay, let's just first try to do some normal dragility stuff. This is minus k Sure. Okay, cool. So the equation that we have is, suppose I'm just going to write this in terms of velocity completely. So dr d square r by dt, so it's just like d by dt of v, isn't it? So dv by dt, that's equal to minus gj hat minus k times of v, right? So vector over there. Cool. That is useful, I guess. Right, so once we can find out the velocity, everything else will be pretty easy. So initially the velocity is just v0, which is just something, we don't really care. Just want to solve this differential equation. Yeah, I mean, I guess just split into xy components. So just have, let's call the x component as u and the y component is v. No, they're already using v, so let's call that w. So u by dt, or you can just call it vx. So dvx by dt equal to negative j. That's not there because it's in the y coordinate. So just minus k times of vx. So it's a harmonic oscillator already. Sure. So what do you have? You just have vx equal to something like sine of, so what, square root of k. Yeah, so just minus omega square, isn't it? Just sine of square root of k times of t, some constant, plus d cosine of square root of k times of t. Then vy would just be something like, oh yeah, so dvy upon dt, that thing is just minus gj hat, so g minus g minus k vy. Sure. I'm not seeing this in, am I? What should I do? Oh, I can just call this w, so w, not omega. So call this thing u will just be like vy plus g by k. Let's call that this thing, so it just becomes du by dt equal to minus kdu. So then u will be something like that, but then so u being something like that, it just means like vy is just minus g by k plus c sine of square root kt plus d cosine of square root of kt. Cool. That is the thing, I guess. So okay, that does it. Sure, that looks okay to me. Now let's just try to put some stuff in. So at t equal to 0, your velocity is this stuff. Okay, so we just have, wait, what is y0? What is y? Y0 is just some point, isn't it? So initially it's just all 0, and then you just got, I'm just gonna call this b0, the initial velocity component. I mean, it's just some coordinate, like, yeah. So at 0, what happens is that it's just b, so b would be something like that. What about these guys? So you're not giving me the other thing, are you? Something is bizarre about this, isn't it? Just a minus of that. Did I not do this correctly or not? I think I did this correctly. Sign of that. Oh, okay, I did not. If it was like d square, then it would make sense what I'm doing, but now it doesn't. Oh, I'm really stupid. I'm not. It's just like, it's an exponential. It's an exponential. How could I be so stupid? Really. But anyway, so yeah, I see it. I see it now. So just like e power minus k times of t. Yep, that's what it is. So at t equal to 0, it's just this quantity. Let's call that Vx0. Right, that's what Vx is. And similarly, we just have like Vy is equal to minus g by k plus this stuff. So just Vy, so Uy0, but sure, it's just some constant. So here, let's put it as c for now. C e power negative kt. What is this? So Vy0 will just be minus g by k plus c. So we just have c equal to Vy0 plus g by k. And that does it. Sure. So you got these guys, the xy component. So what do you want next? Now we want the r component. Sure. So just have r is equal to, just integrate this thing. So just Vx0 e power negative kt. Well, integrate just got this upon k negative right from this is extremely weird, isn't it? From 0 to t, isn't it? So at 0 this would just actually no, just whatever that thing is, just constant. So at 0 there, which would be like this Vx0 on k. I mean, okay, it is an increasing function, but still it's weird. So it's just r x, I mean call that x directly. Not y, just integrate this thing is minus g by t plus Vy0 plus g by k upon k, so just k square over there, and that's a minus actually. Plus some kind of constant, right? So when you put 1 over there, what do you get? This cancels. It's supposed to be k over there, so at equal to 0 this is like not gonna matter, and so yeah, I just wanna have plus 1 and then 1 minus, yep, the usual. That's your r, isn't it? Sure. Okay, so v cosine alpha is just the Vx0 thing, so that upon k 1 minus e power negative kt. Yep, that's okay. And this as well, just sure, yeah, it's exactly just that. So just like what is Vy0 upon k 1 minus e power negative kt, and then combine that with this thing, which is g by k square. So you have g by square, so it's cool, so just g by k square minus e power negative kt minus kt. Yeah, that's your law. And once you have this, everything's derivative from that. Okay, that solves this. Question number 7. Question number 7 is please call his head.
तुमने कल रात को फोन किया
अरे हाँ, अरे वो कॉम्पार कर
अभी फिर से आ गया दूसरा सेगमेंट
अभी क्या
अभी तुरंत आया
कॉम्पार का
हाँ
कब सबमिशन फिर
नहीं मंडे को सबमिट किया तो मार्क्स और बोनस मिलेंगे ट्यूटोरियल है वैसे लेकिन अगर ट्यूटोरियल से पहले सबमिट किया तो 2 बोनस मिलेंगे तो अपने को बोनस चाहिए इंसेंटिवाइज मैंने पिछला ट्यूटोरियल अब तक साल भी नहीं किया पूरा इसको इंसेंटिवाइज कर दिया उन्होंने तो अब 1-2 घंटे में करके सबमिट कर सकते हैं मैं वैसे सोच रहा था कि विंटर के लिए जो इंटर्नशिप का अप्लाई करना है ना इसरो में कर सकते हैं 50% मतलब अगर स्टाइपेंड वगैरह का तो ठीक है, मतलब 10-15 हज़ार रुपये तक हो जाए, बट हमें स्टाइपेंड से अभी के लिए तो एक्सपीरियंस इसरो में अगर किया तो मतलब वो हम लोग रेज्यूमे जो भी अच्छे से दिखा सकते थे इसरो का भी डीआरडीओ में मिला मुश्किल है, तो वही पूछ रहा था, तो मेरे को दोनों प्रैक्टिस नहीं मिल सकता अभी इंटर्स को नहीं मिल सकता, क्योंकि बीच में कुछ जगह पे सिक्योरिटी लीकेज होता है, मतलब लीक हो गया था डाटा वगैरह, उसके बाद में इंटर्न और फुल टाइम हायर पे थे कि बहुत ही ज़्यादा स्टूडेंट प्रेफरेंस वगैरह कुछ का नहीं थे, तो फिर इसरो में रिलेटिवली इजी